In this example, we have a golfer. He's playing a hole in which the horizontal distance from the tee to the pin is 200 yards, but the green is on a hill that has an elevation 25 feet higher than the tee. If the golfer hits the tee shot at a 30-degree angle to the horizontal, what initial velocity will result in a hole-in-one? Okay, so we have, again, a whole bunch of assumptions kind of nested into that problem. So we know that we're firing the ball from ground level out and over. But we know that the green has an elevation that's 25 feet higher than the tee. So the tee is down here. We're going to put the tee at the origin. So that means that our initial position which remember is x0, y0, would be 0, 0. Right? So we're going to put 0, 0, initial position right there. All right, then we're going to shoot the ball up, right, with our club, and it's going to go up and over. And it has to get to a distance that is, now this is a little tricky. You have to read carefully. So the distance away is 200 yards. So 200 yards, but a height of 25 feet higher. So that's a little messy because those are different units. One is in feet and one is in yards. So you could either convert feet to yards. Yuck, we're not going to do that. Or you can convert your yards to feet, and that's what we're going to do. Okay, so we know that over here, its end position would be out. So let me cross this off. 200 yards, well, I guess I can make a note here. 200 yards is 600 feet, right? Because there's 3 foot in a yard, right? Times 3 feet per 1 yard, right? Okay, so that's multiplying. That's conversion factor. So that means this is 600 and then 25 because it's up 25 feet higher than the position of the tee. All right, lovely. All right, now what about its firing? Do we know how hard we're hitting it? No, because that's what we're kind of looking for, right? Initial velocity, which will be related to that. So we're looking for that initial velocity, which will be this vector. So we don't know what its initial speed is either. We do know that it's at an angle of 30 degrees. Okay, so our initial velocity, which if you remember is u0 v0, is equal to k cosine of 30 degrees, k sine of 30 degrees. Now, luckily for us, the cosine and sine of 30 degrees are known quantities because we memorized our unit circles back in pre-calculus. 30 degrees is the angle that's right here. Right? So it has a cosine value of the square root of 3 over 2 and a sine value of a half, right? Because it's pi over 6. All right, so this is really k times the square root of 3 over 2, and then this is k times a half, or k over 2. Well, that's going to make things easier because we actually have values. So I'm just going to segment this piece off. This was all of our work. All right, so now let's go find that position vector valued function. So r of t equals, now remember the formula, it's u0t plus x0, and then negative 1/2 g t squared plus v0t plus y0. Oh, and g, gravity. Again, gravity, g is 9.8 meters per second squared because we're metric. Oh, no, we're not. No, we're not. I don't know why I thought we were. We're in feet and yards. That's not 9.8. That's 32. It's 32 feet per second squared. That's the other one. Because we are not metric. We're in the imperial system. I was just daydreaming there for a second. All right, so in the imperial system, which is the feet and the yards, feet and yards, that would be imperial. So that's going to change things, just in terms of the negative 1/2 g. So u0 would be k times the square root of 3 over 2 t plus x0, which is 0. So I don't have anything to write there. And then negative 1/2 times 32 is negative 16 t squared plus, and then this is 1, or k over 2, or 1/2 k times t plus y0, which was 0. There you have it. All right, now it hits the ground, well, hits the hole at, or reaches the hole. You're trying to get it as a hole in one. It reaches the hole at x equals 600, y equals 25. So we set each piece. So we say, okay, so k squared root of 3 over 2 t equals 600, negative 16 t squared plus k over 2 t equals 25. And we are going to solve with Maple. Right? It's too much of a pain to do this by hand. All right, so let me close this and grab a new one. 1 second. Oh, and I should show you. To make a section, what I'm doing is insert section. You can also do it with control period. All right, so this will be example 4. I'm still going to copy and paste. So I have the command kind of written up here. So I'm just going to copy and paste that, and then I'll modify it. All right, so I have my solve command in here. There is a square root in the palette, but I just write sqrt. I don't feel like bothering with it. So let's see what happens when we run this. Okay, so now don't be freaked out. What's happening here is that it's giving us square root of square root of. So the way to avoid that is to start putting decimals everywhere. And it should, if I'm not mistaken, give us decimal approximations for things. So let's try this. There they go, right? So what's happening is the square root plus or minus, that's what it was showing us. That's that root of function. Okay, so we can see, again, the negative time, oh, let me make this larger. The negative time is useless. So we're going to ignore this combination over here because you can't go back in time before you shot the tee or shot the ball off the tee. So we really want this one right here. So we know that the time of flight, t is 4.482, let's just call it that. So 4.482 seconds. That's the time of flight. I'm just writing that down behind so you can see. And then the other one would be k, which is actually our speed, which is 154.579. And that would be feet per second. So feet per second. So this is the initial speed. Not the initial velocity, but the speed. So I don't want to circle it, right? But those are two very useful things to know. So now we have to go back to what it asked for. So the initial velocity. Right? Because that's what it was wanting us to find. So the initial velocity would be k, which is 154.579 times the square root of 3 over 2, and then 154.579 times a half, right? I'm substituting into here, right? So I just need to find these numbers, and we'll be good. Okay, so let me go back to Maple, and I can just copy and paste. So I copy that answer, and I say, hey, take that answer times the square root of 3 divided by 2. There we go. Oh, and it's going to give me an exact answer unless I put a decimal in there under the square root. So I get 133.869, and then I would do the same thing, but get rid of the square root part. And I get 77.289. So those two are the two components for our initial velocity. So the initial velocity would be 133.869, comma, 77.290, because the 5 would round that 9 up. And that would be feet per second. Technically for both of the components, but we just kind of write it at the end. There's the initial velocity. Now, I'm not going to do the next problem because it's part of an assignment for you. So you are going to work on this for an assignment for Maple. You're going to find the initial velocity vector required in order for a pitcher to throw a strike. This is baseball, just for the record. I mean, I guess you actually, I take it back. You don't have to think of it as baseball either. Okay, so let's expand this. So this problem is deliberately left very open-ended because it'll be your job as your assignment to show all the things you assumed. So you have to start by identifying information you need and what assumptions you're going to need to make this problem. So first of all, pitcher and strike could be, so these will be the assumptions that you need to figure out. And then you're going to have to find facts. So are you talking about baseball or are you talking about softball? They both work, but you'll have to clearly label which one you're doing. And then from there, you have to then figure out all sorts of things, right? So you have to also assume the height of the pitcher. You're going to have to make some rounding and estimations here. You can get known facts as well based on those assumptions. So you can say, look, I assume we're talking about softball, and you can go look up the distance from the mound to the batter. You can look up the strike zone. You can look up, right, distances. I'm just going to write distance, strike zone, etc. Right? It'll be your job to lay all of this out and figure it out. You're going to have to go search, perhaps, on the internet for these things. Matter of fact, you'll definitely have to go search in the internet for these things. And so, are you talking about? And I should also add, not only baseball, softball, but are you talking professionals? Are you talking so pros? Are you talking about Major League Baseball or Major League Softball? I don't know. Is there Major League Softball? Are we talking about college? Are we talking about the Olympics? College, high school? What are we talking about here? So you want to really lay out what your assumptions are and then figure out the facts from there to be able to set up the problem so that you can do it like this. Right? So the only other thing I would say is, in general, you're probably assuming this is a two-dimensional setup, right? Just because you just assume you create a plane that has the batter and pitcher on that same plane, right? So, but you could work on a three-dimensional setup if you wanted, but that would be much more difficult. So I would recommend trying to set up a 2D setup with all these pieces and then figure out your vectors and then be able to solve it. All right, so you'll have a good time with that assignment. Make sure that you clearly state and label everything in your Maple because it's a Maple assignment. The only other thing I will mention is that in Maple, if you want to start typing and writing things like my assumptions are blah, 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 you want to click on the text mode up above where it says text. So that way you can type and you can see that this is not, it doesn't look like the code, right? When I click on mathematical code, it puts a blue box around it. So that's how I know I'm in code. But down here, I'm not. I'm actually in text. So it can look like text. I can change my font. I can do whatever, right? And so from there, oh, please don't use Tiger though. That's a terrible font to use. So from there, you can can go and type the pieces you need and then do the math pieces you need, and so on.